So I know in the printed notes I've provided the derivatives of the 6 inverse trigonometric functions. But I wanted to create a video with at least one of them where I talk through how we arrive at those derivatives, because it's not obvious when you just look at the derivative of arc sine is such and such. I don't want to give away the ending here. Okay, so I want to show you where those derivatives are coming from. So suppose we want to differentiate the function y equals arc sine of x. It may be helpful in this video if I express that as inverse sine with this notation. That's just a change in notation, though. I mean, you can write your inverse sine function either this way as arc sine or with the inverse function notation. I'm going to use this just because then the concepts of algebra that I'm using may be more obvious if I use this notation. So if y is equal to inverse sine of x, that means that y is the angle that you plug into sine. So sine of y should give us the result x. Another way to look at how I got from here to here is suppose you take sine of both sides. So sine of y equals sine of inverse sine. So with those inverse operations, they'll undo each other and you'll have just the x there for sine of inverse sine of x. Okay, so if y equals inverse sine of x, then sine of y is equal to x. Now I'm going to differentiate from there. So suppose you take that equation and differentiate both sides with respect to x. So take d dx of sine of y equals d dx of x. Okay, and I'll do the easy side first. So derivative with respect to x of x is just 1. Derivative of sine of y. So this is an implicit function because it's not sine of x. If this was get overexcited. If this was the derivative of sine of x, it's just cosine x and that's it. If it's the derivative of sine of y, where y represents some function of x, then we need to be careful. We need to use, it's actually the chain rule, but implicit differentiation is what you should remember from calculus 1. So the derivative of the sine function is the cosine function. Leave the inside alone, times the derivative of the inside. So times the derivative of y, which is, well, I'll write it as dy dx, equals 1. You could write y prime if you want, but it starts to look like y to the first. It gets confusing. Okay, and we're looking for the derivative. So I could solve for the dy dx here by dividing both sides by cosine of y. So here, divide both sides here by cosine of y to get this here. Okay, but we want to write our answer algebraically if we can. So remember that we have an identity that relates sine of y and cosine of y. So remember, I'll put recall. This is where I was saying it's important to memorize your trig identities as soon as possible. We're going to use a lot of trig in Cal 2. So there's a identity called Pythagorean identity in trigonometry that says sine squared plus cosine squared equals 1. And I'm putting the angle as y in this case since that's what's involved in this problem. So cosine, if we solve for cosine of y, so cosine squared of y equals 1 minus sine squared of y, and sine of y is equal to x. So sine of y here is equal to x. This is x squared then. So this is 1 minus x squared equals cosine squared of y. And so if we take the square root of both sides, cosine y is equal to plus or minus the square root of 1 minus x squared. Remember that when you solve an equation by taking a square root, we should include the plus or minus. Okay, so in our final answer back over here, so our dy dx, our derivative, is equal to 1 over cosine of y, which is equal to positive or negative square root of, here, 1 minus x squared. But we need to pick one or the other. It's not going to be both. So let's think about it. Sorry, I'm going to come back here. If y is equal to inverse sine of x, so y, each of the inverse trig functions has its own restricted range. For inverse sine, we restrict the range to negative pi over 2 to pi over 2. I'm writing the portion of the unit circle that corresponds to. And the reason, for some quick background on that, so here's your sine graph, very sloppy sine graph, fails the horizontal line test. So if we leave it alone, it does not have an inverse because it's not 1-to-1, fails the horizontal line test. So we want to put a restriction on this function so it passes the horizontal line test. So we choose to chop off just this middle section of the graph, just the section as x goes from negative pi over 2 to pi over 2. And so that way we can define an inverse sine function. So that's where we end up with this restricted range from negative pi over 2 to pi over 2. So that means that y must be in either quadrant 4 or quadrant 1. In either of those quadrants, cosine will be positive because cosine is associated with the x-coordinate. Right? So cosine of y is going to be positive root of 1 minus x squared. So the positive root, that means I don't need to write plus or minus. I can just write it as the square root of 1 minus x squared. Oh, and I'm sorry, there's a terrible glare right where that's written. But this is how we figure out that the derivative of inverse sine is 1 over, sorry about the glare, but that's the square root of 1 minus x squared there.